things, let's start off with the shape of the normal distribution curve. It is bell-shaped, it has a single peak, and it's also symmetrical. The area under the curve is equal to 1, and half being to the left of the mean, and exactly half being to the right of the mean.
So what's the definition of a normal distribution? Well, a normal distribution is a type of continuous distribution that has a mean represented by mu and a standard deviation represented by sigma. The mean and the median are the same, and they're located at the center of the normal distribution curve. And these normal distribution curves, the larger standard deviation means that the normal curve will be more spread out.
There are many real-world applications that can be used with normal distribution curves, such as the IQ scores, flip a coin, and statistical inference procedures.
So what is the 68, 95, and 99.7 rule? Basically what it means is that 68% of data values lie and fall between one standard deviation away from the mean. The 95 represents that 95% of the data values fall or lie between two standard deviations away from the mean. And the 99.7 rule means that 99.7% of the data values fall or lie between three standard deviations away from the mean. Alright, so let's start with an example. The distribution of adult American men's heights is approximately normal, with a mean of 69 inches and a standard deviation of 2.5 inches. The first part of the question asks us to draw the normal distribution curve here, which we have already drawn out here. So, the next question asks, what percent of men are taller than 76.5 inches? So first we need to see how many standard deviations away 76.5 inches is. In this case, it's 3 standard deviations above the mean. And according to the 68, 95, 99.7 rule, that would mean that it's that below and above 3 standard deviations of the mean is 0.3%. But in this case, we're only doing above, so it's 0.15%. The next question, between what heights do the 68% of men fall? Now, in this case, 68% of men is only 1 standard deviation. And so we can just look here at our distribution curve and see that 66.5 to 71.5 is where the middle 68% of men fall.
So question D says, what percent of men are between 64 and 74 inches tall? So, because of the empirical rule, these two numbers are 2 standard deviations away from the mean. So the answer would be 95% of men are between 64 and 74 inches tall. Question E says, a height of 61.5 inches is how many standard deviations away from the mean? So once again, because of the empirical rule, 61.5 inches is 3 standard deviations below the mean.
Alright, moving on into the second example, we have the mean IQ score is 100 with a standard deviation of 15. The first part of the question asks, a person with an IQ of 125 would be within how many standard deviations of the mean? So one standard deviation would be 115, another standard deviation would be 130, so 125 would be within 2 standard deviations.
So now B asks, what percent of people have an IQ between 85 and 130? So basically, 85 would be 1 standard deviation to the left of the mean, and 130 would be 2 standard deviations to the right and above the mean. So that would be 68% plus 13.5%, which equals 81.5%. And now C says, a special organization only accepts people with IQs in the top 2.5%. What score would an individual need to qualify for the organization? So we know that 2 standard deviations above the mean would be 130, so anything above that would basically be 2.5%. So in other words, a score of 130 or above would have an individual qualify for the organization.
Bye.
See ya. Thank you.
See ya.